This meeting is being recorded.
So, good afternoon to Dr. Nohayati and our friends. We are from Group 8. Today, we will present our work design project on W&S plastic. Next. So, our team member have Aino Mofrida, my name is Chang Jia Singh, Colin Ping, and So Young Seng. Next. First, let's start with the company background. W&S Plastic is located in Gulai, Johor. It is actually a subsidiary of an Australian company with over 45 years of experience. They are not just a normal plastic factory, they are very advanced. They specialize in making medical service and cosmetic products. Because of this, they have an ISO Class 8 clean room and use Industry 4.0 system for real-time monitoring. This shows that the factory operates at a very high standard. Next. So why did we choose to improve this line? We identified a core issues, a mixed match between automated machine cycle and manual operator workflow. First, here are the key 10 points. Firstly is productivity gap. We saw the operator waiting idle while the machine was pulling. Secondly is inspection bottleneck. The manual visual inspection takes too long and slow everything down. Thirdly is fatty reach. The operator has to stare at the product to find small defects. This causes eye fatty and makes it easy to make mistakes. Next. Next. Our objective of this study are to analyze the existing manual workflows and man-machine interaction using quantitative techniques, including stopwatch type study, predetermined 10 type system TTS, and activity sampling. Secondly is to identify critical production bottlenecks and productivity gaps with a specific focus on manual visual inspection, inefficiencies, and other type within the man-machine interface. Thirdly is to propose effective work design improvement that optimize cycle time, enhance task synchronizations, and decrease operator cognitive fatigue to consistent production improve. Our store focus on product A, which is a cosmetic track. The process cover are raw material preparation, injection molding, inspection, and packing, specifically during the day shift productions from 2 p.m. to 5 p.m. Next, I will pass to the next presenter.
So this slide will explain our literature review. The first one is we develop or we search for concept of work design, and effective organization of tasks, working stations, equipment, and workflow to fit the abilities and limitations of the human being by enable 2023. And the second is time measurement concept. Stopwatch time is an measurement methods that rely on the quantitative assessment and combination of standardized and predefined time values from Ain et al. 2025. The third time measurement that we use is activity sampling or work sampling. It is the method that is used for estimating the proportion of time devoted to different activities within a specified time frame by Sar et al. 2021. The third literature review is performance ratings and allowances. It is a technique of work measurement employed in the evaluation of the rate of operation and effectiveness of an individual in doing job compared to a certain standard or the normal rate of performance by Henneman et al. 1987. The next literature review is plastics manufacturing. Plastic manufacturing generally refers to the process of converting polymer materials into finished or semi-finished products through various techniques of forming and shaping. Next. Next is principles of motion economy, which is the workplace layout. The principles of motion economy highlight the importance of proper workplace layout to reduce unnecessary movements and operator fatigue. Placing tools within easy reach using drop delivery mechanisms and providing ergonomic workstations can improve efficiency and productivity in manufacturing operations by Nibel and Frivolts 2023 and Cons from 2019. Next is plastics molding process in manufacturing process. Plastic molding can be termed as the backbone of plastics manufacturing, where molten plastics are molded into desired shapes using molds based on research by Yusuf et al. 2004. The injection molding process entails material feeding, melting, injection into the mold cavity, cooling, and the eventual ejection of the molded product by Singh and Verma 2015. Next is terminology of molded plastic product. Moldings made from plastic materials can also be categorized based on the product type, dimension, or manufacturing stage. Moldings already completed at the end of the molding stage are mostly known as molded parts or plastic components based on research by An et al. 2024. And the last is ergonomics in manufacturing process. In manufacturing industries such as plastics manufacturing, ergonomics plays an equal crucial role because of the nature of operations carried out, which tend to be repeated and laborious for the workers from research by Mohammed et al. 2021. Next, I will pass to the next presenter.
For our methodology, this study focused on analyzing the work design of product A at WNS Plastic. We used a combination of quantitative and qualitative methods. Quantitatively, we conducted time study to measure both manual and machine operation in the production process. Qualitatively, we also conducted interviews with the assistant general manager and production manager to better understand current practices, quality requirements, and operational constraints. The study focused on product A, a domestic tray, because it has a clear workflow and involves both manual and machine activities, making it suitable for work design analysis. Next. The main tools used were the stopwatch method with setback approach, predetermined time system MTM1, and activity samplings, and a total allowance of 50% was assumed, consisting of 5% personal allowance, 7% fatigue allowance, and 3% unavoidable delay allowance. Next.
So this slide shows the analysis of the current situation, which is the current workflow for product A, cosmetic tray. Next, the process categorized into two parts. The first part is pre-molding process, whereby the estimated weight of raw materials is approximately 35 kilograms that will be poured by an operator into a hopper dry bin for the 130 mixing drying phases. The temperature must not exceed 100 degrees Celsius and must more than 30 degrees Celsius. And then the dried raw materials will be connected to the molding component machine at the production site. After that, the operators will inspect the quality of the component product every 2 hours using the SPC chart here, as you can see, in the quality control room. And then after that, the operator will inspect the tray or the cosmetic tray using the general prototype that prepared by the customer. And as you can see here, they use the jig and fix. Next. So for the second part is post-molding process. In this process, the operator is responsible for inspecting each tray for any surface defects or abnormalities. And then the packing procedure is done taking into consideration safety and ergonomics, like the weight of the box is controlled ranging only between 3 to 5 kilograms. After all of the process, we identify that the current process observation is having 4 processes. The first one is raw material loading, which is manual element. It is start when the operator's hand touches the raw material packaging, and it ended when the operator puts back the empty raw material packaging to its original position. The second process is the material mixing and drying process, which is the machine element. When the machine starts operating, indicated by the operating sound and status display, and then the end is when the machine stops operating, as indicated also on the monitor screen. The third process is injection molding operation, which is a machine element. When processed material is transferred from the mixing and drying to the molding machine, it ends when the machine arm ejects and places the molded product next to the operator for inspection. And the final process is visual inspection, which is the manual element. When the operator picks up the molten product for inspection, it will end to the when operator places the inspected product into the designated storage box. Next, I will pass to the next presenter.
Next, let us move on to the flow diagram for product A. This slide visualizes the actual physical movement of the material through the factory floor. If you look at the layout on the left, the floor follows a logical circle from right to left. It starts here at the blue zone, which is the raw material store. Then the material is transported to the brown zone for the injection molding process. The most critical part is here, the green zone. This is the packing area where the operator performs manual inspections and packing. Finally, the floor ends at the pin zone where finished goods are stored. Next. During our site visit, we observed that the facility maintains very high safety standards. First, they have clear emergency evacuations maps. Second, hygiene is strict. Everyone must wear PPE like gloves, head nets, and shoe towels. This is important because they produce cosmetic tray, so we must protect the product from dust. Third, the first aid kits and fire extinguishers are easy to buy at the workstations. Lastly, they follow strict social distancing rules to ensure the worker safety. Next. Finally, to ensure our data is valid, we cross-reference our study with internal documents. Please look at the production schedule got in the pictures. This is very important because it tracks the target cycle time. We use this plot to check if our stopwatch reading will accurate against the company standard. Besides that, we also check the raw material law, which confirm that the material preparations follow the correct standards. Next, I will pass to next presenter.
To begin our analysis, we designed the snapback method for our stopwatch type study. This allows us to reset the timer to 0 after every event, giving us direct and accurate reading for each specific task. We observe the 5 complete cycle. As you can see the table, 4 main element study, which is the raw material routing, manuals, mixing and drying machine, injection, molding machine, visual inspection is manual. Each element also 5 cycle, performing rating apply to manual tasks only. Next. The final calculate standard time is 55.58 seconds. It is important to note that because the machine is not suffer for fatigues, they achieve no allowance, ensuring our production schedule is more efficient and realistic for the human operator. Next, I will present about the predetermined time second analysis were conducted using MTM1 at the packing workstation. The tasks was systematically divided into left hand and right hand method, where the left hand handle the tire retrieval while the right hand perform inspection and stacking. The motion is reach, grab, move, position, and release. The total motion time record was 89.6 TMU, resulting in the persist normal time, which is 3.22 seconds. This manual task is comfortable within the machine out and cooling time, ensuring the proper product cooling while preventing the defect such as warping. In addition, the economic control such as limiting loss, which is 3 to 5 kg, reduce operator fatigues and MSD demonstrating that and optimal balance between productivity, quality, and worker well-being. I will pass to the next member.
So next I will explain the activity sampling part. Activity sampling was conducted to understand how the operator time was distributed during the production process. The observation was carried out from 2 p.m. to 5 p.m., covering half a working shift. During this period, we recorded 116 random observations and categorized them into 3 activities, which is machine operation, manual inspection, and idle time. Next. This is the data that we use as assumption to calculate the standard time using the activity sampling method. Next. To ensure the observation was unbiased, we used a random number table. Random numbers were generated to decide the exact time of each observation during the working period. At each randomly selected time, the operator activity was recorded based on the 3 parameters. Next. And here are the calculations for the number of observation and the error percentage by referring to a 95% confidence level and 5% error. Next. The result shows that most of the time was spent on machine operation followed by manual inspection, while idle time was relatively low. This indicates that the operator remained productive during machine cooling time. After applying performance ratings and a 15% allowance, the calculated standard time was 1.36 minutes per unit for inspection and 1.28 minutes per unit for machine processing. Overall, the activity sampling results show that man-machine coordination is efficient and operator utilization is at an acceptable level. Next.
Next, I will discuss about the overall result. The overall result shows that the air time in the injection molding process is primarily driven by the mandatory 18 seconds cooling cycle, which is essential to prevent the effect such as warping, residual stress in the plastic product. Rather than the treating this air time as waste, it is strategically utilized for the inspection and stacking activity within 10-second L window, ensuring no increase in the total cycle time. Manual tasks such as a low material loading and visual inspection take longer due to their cognitive and sensory demands, which is justified application as of a 15% rest allowance. Overall, the current work system demonstrates an effective balance between machine control cycle and human activity, enabling quality assurance without compromising quality. Next. I will discuss about the motion economy principle in the workplace layout, which is having the toss and material placement, use of drop, lever, or injection, economic workplace design. For the use of drop, delivery, or injection, machine undeliver product directly beside the operator. It may the operator movement to collect the product and improve the workflow continuous and efficient. Next. Next, I will present about the implementing work design principle for improvement. To further improve the workstation, work design principles such as motion economy should be strengthened by placing all packing tools and material within the operator normal zone. Unnecessary body movement such as twisting and overreaching can be eliminated. This not only reduce the fatigue but may also lower the need for less allowance. Additionally, the use of proprietary systems such as injection, jig, light sensor, and wide sensitivity scales can standardize reach quality control and prevent the error in packing. This improvement ensures that inspection and packing remain efficient, safe, and fully synchronized with 28-second injection molding cycle. I will pass to the next member.
So here are the revised flow chart that we propose. So the improvement implemented is that combine first off and QC supervisor chair and integrated with operator visual inspection and also isolate large batch only. So next. And this is the revised flow diagram, which we improve the cooling fixture and active cooling we fan are using, and picking performed immediately at machine outlet, and also inspection combined with packing and direct one directional flow between areas. So this will help to reduce waiting times, reduce motion and handling, shorter cycle times, and reduce transportation waste. Next. So in conclusion, this work design study successfully analyzed the production process of product A at WNS plastic using stopwatch time study, PTS, and activity sampling. Total standard time of 55.58 seconds confirms that the production process is stable, controlled, and efficient with machine operation dominating the cycle. PTS analysis verified that inspection and packing tasks can be completed within available idle time, supporting economic and safe work practice. Activity sampling results indicate acceptable operator utilization with sufficient allowance to sustain long-term performance. And manual tasks are effectively synchronized with machine cooling and idle time, minimizing non-value-added activities, while man-machine coordination is well balanced, ensuring high productivity without increasing operator fatigue. Proposed work design improvement can further enhance the worker efficiency, reduce waste, and maintain quality standards. Overall, the study demonstrates that proper work design improves productivity, quality, and economics in injection molding operation. So that's all from us. Thank you.